much for coming. So today I'm going to talk about advancement in space science, technology and exploration. Is it beneficial and necessary? Little bit of background Andrew has already said. So I had an opportunity to attend International Astronautical Congress last year in October and associated events in Toronto, Canada. More than 2,000 scientists, engineers, lawyers and entrepreneurs had attended that, along with the heads of the space agencies and also legislators from various countries. They had one single common interest, that was technological advancement in space. From the interaction with the varied participants of the event, I tried to understand what is the driving force behind their enthusiasm. And in today's seminar, I will share my experience at IAC, and I'll try to explore why our world needs space and why space matters. So the first question, does it really matter? What do you think?
Yes.
Yes, it is. Somebody said no. Yes.
We need balanced opinions here.
So, let me show you what people in general think about spending money in space technology. So, they say no, this is wastage of money, because whatever spending money for space technological development to access space does not give any direct benefit to society. Whatever byproducts we have got from space research, those could have been developed by commercial companies with an aim of profit and making a good product, and which would be much less cost effective. And then second point is, we have a lot of other problems to solve in Earth. And what problems we have? War, we have terrorism, we have environmental changes that we have to solve, and people have already developed a notion that the solution to these problems are kind of mutually exclusive with development in space. And the final thing is money. Money should be used for development of nation. This phrase often is heard when a developing nation launches a space mission, like India. So last year, India launched Mars Explorer mission, orbit mission, and that was heavily criticized because the expenditure was about $75 billion, and it was 0.03% of annual budget of India, and those would have been used for, not for space, but in rural development. So hence, spending money for space technology and exploration is a wastage. But our head of space agencies from different countries don't think so. They think differently. Dr. John Warner, I had talked with Dr. John Warner, who is the head of space, German Aerospace Agency, gave an example during an event in ISA. The example, he asked us to think about the technologies what we have used during the traveling from Australia or from other countries to Toronto. In modern days, use of technologies which directly or indirectly, which are directly or indirectly direct outcome of space research is so obvious that sometimes we take them for granted. After waking up in the morning, we check the weather, which is basically processed data from weather satellites. And for traveling, we have GPS receivers installed in our cars to let us know where we are. And finally, we cannot imagine a single day without high-speed internet or mobile communication. Global communication is heavily dependent on geostationary satellites. Without them, we don't know where would have been. And all these advancements would not have been happened if Sputnik was not launched. So these benefits kind of justifies that space missions for earthbound orbits are necessary. But what are the benefits of space exploration? What are the benefits of exploring the space beyond Earth orbits? I asked the same question, this particular question to the President of International Astronautical Federation, Dr. Kiyoshi Iguchi, and I asked him, how will you justify the exploration, space exploration? How will you justify human space travel, and how will you justify Mars mission, lunar mission? The reply was, it is very difficult to explain, but the relevance of space exploration is obvious and inevitable. The answer didn't stop there. He pointed out one basic instinct of human being, curiosity, to know what is not known, to go where no one has gone before. So, human history of exploration we can trace back to 1500 before Christ. So, during that time, with limited technology and fragile vessels, our ancestors explored over ocean and lands. And then the age of discovery came during the medieval period. During that period, Europe has saw the expedition of Magellan. Vasco da Gama found a new way to go to India, and Columbus reached America. The colonial empire started flourishing. This was probably the most notable era of human exploration till date, and had direct influence on shaping our modern world. Space exploration is the continuation of this history, and which is changing and reshaping our world. Said so these are the driving forces for exploration. So what are the benefits? Innovation. So there are few pictures I am showing. Those are applied in our life, day-to-day life, but they actually directly came from space research on space exploration. This is low-cost ballistic parachute. It was developed for the human space flight, but it is currently used for aircraft landing, safe landing during any accident. And then artificial heart pump. This artificial heart pump, this design was actually from the fuel pump from space shuttle, and from there scientists have converted into the heart pump. And then we have Teflon coated fiber glasses, which was developed for astronauts' garments in space, but now it's widely used in stadiums. Then in medical surgery we have precision robotic arms, which was actually developed for space missions, and then we are using it in medical science. And then we got this very lightweight breathing system, which was also an outcome from human space travel. So this is a very small list, but this list goes on. So these are the technologies that we use, which directly came from space research. And then these are the innovation part. Then what are the cultural effects? Yuri Gagarin's first space flight, and then Neil Armstrong's first step to the moon changed the outlook of humankind entirely. It changed our outlook about the limitation of our travel, how much we can travel, and then you can see this picture. This is very famous picture. This is named Earthrise, and this was photographed from the lunar orbit, and there we can see our home planet as isolated and very fragile. And this image was a driving force for collective environmental awareness and doctors beyond borders. So these are the impacts we are talking about, from what we got culturally from space technology. And last but it's quite obvious that the space exploration always inspires the youth. Then I will talk about few different space missions that and their science goals. The translunar missions. Why would we go for the translunar mission? So why we're interested in exploring in this region and in moon? One interest is search for minerals, but yes, bringing it back to Earth is difficult, and that we still don't have the technology. But the development of this technology will be very interesting. And then research of galactic cosmic radiation. Cosmic radiation is really harmful to human, and how do we prevent or how do we cure this? This is a part of medical study, and that has to be done. And development of technologies for supporting future exploration. This figure is not so clear here, but there are there are few points between the lunar and Earth, Moon and Earth region. Those are called Lagrange points, and there the gravitational force of Moon and gravitational force of Earth nullifies, and there station keeping of satellite can be done with zero fuel cost. And in those installations, in satellite infrastructure, we can do some cutting-edge technology with very low cost, and that could be supporting our future exploration. Then, asteroid missions. Why we are interested? Asteroids are believed to be formed during very early age of solar system, and if understanding the asteroids will be helping us to understand the formation of solar system, and then we will also know how water and organic materials came to Earth. And this is knowing that will help us about the basic question of human beings, about our existence, why we are here, how did the life came here. So, and then asteroids near Earth are always a threat, in 2011, there was an asteroid meteor strike in Russia. 1,000 people were dead and around 4,000 houses were destroyed. And scientists think that dinosaurs have been obliterated from Earth due to the asteroid strikes, and so from those possibilities, how do we prevent Earth from these if these events happen in future? So those research are required, and after that, the exploring the probability of mining and resupply for space missions. Asteroids are full of minerals, and those can be extracted. If it can be extracted and supplied to the ongoing missions, that would be very interesting, and which is a bit of interest of AXA, because we are working on off-Earth mining. And then Mars mission. Why we need to research on space missions on Mars? Because in the history of evolution of Mars and Earth is very similar. The difference is that on Earth the geological evolution has been destroyed, but in Mars, beneath the crust of Mars, that history has been well preserved, that we assume. And we want to understand, if we can understand the formation of Mars, we can will be able to make more develop other geological research in Earth. And then collecting data for manned missions. We need to collect data for manned mission if we have try for any future mission on Mars by human, and then exploring the possibility of human habitation, not only mission, but exploring the possibility of whether we can have make a colony there. And finally, how does these work help us as a whole? So, space research addresses global challenges. We are using satellites for monitoring global warming. Then, capability of global protection, as we say, the protection from materials, and then space debris removal. Space debris is a very now is very concerned in the space community, and how do we remove the space debris is very important for us for future space missions. And then managing the threat posed by solar storms to the people and space infrastructure. Space research is required for managing these threats, and doing so with in a well coordinated and coherent international cooperating environment. Nations will build trust and understanding among them. So finally, space travel, exploration and related research have similarity with the railroad development. In the beginning, no one knew whether a railroad was economically viable or not. In the course of the 19th century, they represented human conquest of natural obstacles with consequences for humans' view of nature and our place in it. Similarly, space program has technological challenges, and the economic benefits may arise in even longer term than railroads. But it is expected that the importance of space conquest will be much bigger than railroad and aviation. With Stephen Hawking's quote, I want to conclude the first part of my presentation. To confine our attention to terrestrial matters would be to limit the human spirit. And this is about my view developed during IAC, that why we need space research. And the events that I have attended in Toronto, that is Space Generation Congress, where the young space professionals related to space come together, and they have few working group meetings to develop, to project future policies. And then United Nations Office of Outer Space Affairs had organized one workshop on socio-economic benefit of space, and then finally International Astronautical Congress. Space Generation Congress, there were 5 working groups. Working groups were onboard servicing, CubeSat swarms, communication networks and policy challenges, ethics and policy of new human space exploration strategies, entrepreneurship, and its role in space industry, Earth observation for maritime services. I was in CubeSat swarms and communication networks and policy challenges working group. In that working group, we tried to find out what could be our future policy on CubeSats, because CubeSat is viewed as a threat as space debris, because their lifetime is only 3 to 4 months, and then after that it just stays there. And how do we remove the threat, and how do we make the policy so that that can be used, CubeSats can be used in a more fruitful way. So similarly, other working groups also provided their reports on the future policies, and in few weeks ago there was in United Nations meeting, they have presented our reports. And then United Nations Office of Outer Space Affairs workshop, that was dealing with space application for global health. I mentioned already about the Doctors Beyond Border, and how we can improve using space related technology, mainly on using communication technology. How we can improve the situation and for in global health, and then maritime application of space technology that I couldn't attend because of because then there are parallel sessions were running together. And then finally International Astronautical Congress, several technical sessions covering various fields of space. Then there was global networking forum where there were various leading actors in space where there we could interact, and then next generation plenary where a few young space scientists came with their presented their work, and then the expo of various corporations. And this is very interesting. This photo is our official presence at ISC, and this one is Dragon 2 SpaceX Dragon 2 capsules control panel. So it looks like very similar to this Tesla control panel, and it looks very sleek, not anything like what NASA developed. And thank you very much for your attention. These are a few pictures with Charlie Borden, Administrator of NASA, then Chairman of ISRO, and then with President of IAF, and obviously Niagara Falls.
Questions, Sanat?
Yes?
A bit tangential, but you mentioned at the end like CubeSats being a threat. Is that I never played with that being an issue?
No, it's really we view it as a threat. Although it has its own benefits, but still, if we don't have any deorbiting mechanism, then it will be very difficult. That's why we want to limit the CubeSats within 700 kilometers of range, because beyond that, if we launch CubeSat, it will stay there if we don't have any deorbiting mechanism.
Oh, so you just mean like a threat for them lingering too long and getting in the way of other
Yes,
spacecraft?
yes.
Right, okay.
And say for astronautics, Chippendale have a CubeSat deorbiting device.
But it is not mandatory to put. So I think they are pushing for making it mandatory. We need a mechanism for deorbiting.
What could possibly end up happening
in near future?
When you get your launch permit.
In near future, no, nothing is going to happen.
Yeah, but we're discussing this from the Australian point of view next week.
Okay.
How the legislation can be changed. And it's the sort of thing that they'll.
Mm-hmm.
More questions? Did you consider there's an article in the most recent version of Coordinates magazine on why India has a space, the reasoning behind their space policy. Have you seen that?
Reasoning behind, no, I haven't seen that. But we are pretty sure about why we need space policy.
Yeah, I mean, they've used some of the points that you made, they make others as well.
Okay.
So even a country in India where you think there's a strong argument not to have space policy, they actually have quite strong arguments to have it.
Yes. Strong argument still there, but yeah, I can't remember the statement by Dr. Vikram Sarabhai. His strong statement basically put us in that course of ISRO. So it was very strong, and it says that the summary was that we really don't want to left behind during when the other parts of the world goes towards space, and which is quite justified, because we don't want to think us irrelevant and dependent on other countries for launching and communications positioning.
This might be a little off tangent, but how did you personally get involved in the Young Space Leader program?
And going on, how could
okay,
other people?
So that was.
And how could other people who are interested in it do the same thing?
Andrew sent me that you can apply. Then I applied, And it's but if you want to apply for that, now it is not the time. I think that for this year it has been over. It's over. You just keep in touch with the IAF website, International Astronautical Federation, IAF.org website. There they publishes all these call for nomination for different leadership plans.
If the deadline is passed, it's only just passed. So I know
like a week ago.
I know that an application went over to Mike is just really recent. So it was just last week.
Yeah, on the 6th it closed.
Oh, okay.
I think that's a different program though. That only has 5 units, Sanat's only have 14.
Really? I don't know. It's the same one. He was listed as a winner last year.
There's another one as well.
Yeah, okay.
So yeah, if you want to go to, it's in Mexico next year.
It's Mexico, yes,
Is this year's Jerusalem, next year's Mexico.
And 2017 Australia.
2017 Adelaide. Whew. Get more exciting than that. Other questions? Come on, ask him some tough questions. Like what about the space economy stuff?
Not my stuff. Yes.
So you talked about the benefits of space sort of being blue sky research, like we don't know what benefits are going to come from it, but isn't that equally applicable to other fields of research, and how do you sort of trade off money to space versus money to Antarctic exploration, which could have similar benefits in the future? Or even when you talk about some of the developments, they could have easily just come from F1 racing, things like that. So how would you trade off that sort of economic decision of which area of blue sky funding research should you fund?
It's a very good question. A difficult question to answer. But it's, you can say that, you can classify it kind of, we don't know. But to a certain extent, we already know, right? And we know that there are possibilities that we can do. Because when, and which is relevant also. That's why, for Antarctica mission, yes, they're also, I think, similarly important, but this one has to go on also.
But why?
I would add something about this. The general tenor of this presentation has sort of been like for scientific benefits and so on, which is probably not surprising given that the emphasis of the Astronautical Congress is very much driven out of the agencies, right? But the mantra that I'm going to be pushing from here is that space doesn't burn money, space makes money, right? We're doing a study with NASA at the moment about how mining can be used to support an economy on Mars, right? And the first question I want to get asked is the colony there to support the mining, or is the mining there to support the colony, right? And NASA's mindset is, oh, of course the mining's there to support the colony, as if the colony is the point, right? But if you've got a mining company that goes to Mars to make money, the colony's there to support the mine, right? And you make money. Once you've got investors investing in things, it happens. Trying to get conservative government to fund space agencies to do that sort of thing is much more difficult. What's that?
Sorry to interrupt. I was just going to say that seems to be a fairly common theme for Australia.
What's that?
Pick it up.
Basing our existence upon money. I mean, I think it's a really good economic model. I think, but it was just sort of a humorous observation from
yeah, but it's an opportunity, right?
Yes.
Australia doesn't have a space agency, doesn't really have a space industry, but we do have a very strong mining industry. So if we are going to do something in space, why would we not do mining? We've got the two biggest mining companies in the world registered here. Yeah.
Do you also agree with like Elon Musk's view of thinking that it's necessary that we kind of go into space for humanity's sake?
I don't care about that. I mean, the problem with going there is you attract wackos, right?
Well,
Just talk money. Which I'm a bit surprised that Elon Musk, for instance, doesn't talk money, because no one makes money like that guy, right? He's got 3 of the biggest brand names in the world to his name. I mean, who can say that? So yeah, I guess he's a bit of a dreamer sometimes.
Maybe that's his power, not wanting to make money.
Yeah, I'm not sure. I can talk to you about that later.
But that's like when Facebook says they want to bring internet to Africa. It's like, are you trying to make the world better, or are you trying to sell ads to more people?
Oh no, farm.
Questions for Sanat? Come on. Interesting topic.
Yes?
What's your view on space tourism and its place? Do you think it's more important than other space endeavours, such as mining and researching things we haven't discovered in space?
For the time being, no.
So you think it's more important to be thinking of other things other than space tourism?
Yes.
So you don't think the possible advantages of it, getting more, perhaps if it's profitable, I don't know if it is profitable or not, but getting more money into space industries and just generally giving a wider public image?
For space tourism, first we need to develop the technology. And we need to focus on developing those technology first and then think about tourism, I think. And those technology will come from, suppose, mining. Because if you say, okay, I want to go to space and see how it looks like, I think it's very difficult to get money from people. But if you say, I have these plans to mine asteroids or mine on Mars, and this is viable, then there's a high probability that you'll get money. And when those market has been established, then you can think about, now maybe we are ready for space tourism.
If you want to think about the maritime example.
Sorry, I'm just going to jump in. I would reverse that argument and say that space tourism, for instance, would create a market for mining. You mine water in space, right? So the idea is, if you can deliver something in space for less than $10,000 a kilogram, like water, then you've got a market, right? But who buys stuff in space? If there's a space tourism industry, then you can sell water.
Space refreshments. Space refreshments.
Water's used for everything. Water's used for bio-processing of things. You can create fuel from it. You can drink it. You can grow plants with it. Water's quite important. Don't know if you know. But it costs us, $10,000 a kilo a litre to get in space. So we get miner in space. And this is what I think. What we need is a circuit. We need NASA, for instance, to say, right, deliver me a ton of water in space. And once you've done that, you've got the supply, then you can create the demand. But at the moment we have neither supply or demand, so that market's not being created.
So that is kind of like never-ending loop.
Yeah.
That's right. So you've got to break the loop. And then once you've created this market in space, then you can start building on it. But at the moment, it's a bit of a bootstrapping exercise.
But what maritime did is the primary reason anyone was exploring was to claim land. They thought maybe they'll find things they can trade with, they might find resources, they might find colonies, but they went to claim land. And that's exactly what nations will do in the future. I don't think humanity will have changed that much in the last 500 years.
Yeah. How long did it take the Spanish to start dragging gold back to Europe after they landed? Not very long.
Just a comment about, as you were talking about a bit before about the sort of age of exploration. And it's sort of like, oh, the human spirit wants to be where no one else has been before. And I think that is possibly true in a very specific sense. But thinking about, as you were saying, and all about, colonization, it wasn't really, hey, let's check that out, that looks cool. It was, hey, I think, someone told me there was gold there. It was all to do with that. So, I don't know. I think it's an interesting argument. It seems that, you do something and then a couple of hundred years later you say, oh, well, we had very noble intentions. But at the moment, no one sort of goes, oh, maybe
I
noble
would not say
intentions.
that the intentions were very noble.
Yeah.
I would not say that the intentions were very noble.
Yeah.
But what happened was that those expeditions that shaped our world, and here also many people have that similar interest on space. And if we go for space exploration, and we don't know in next 100 years, next 200 years, where our society will be. And what I tried to make a point was that using from those expeditions we're here, and with these explorations, there will be a positive impact on our society.
Oh, definitely. I definitely agree with you. I just found it fun.
Who's the next Dutch East India company?
UNSW.
Yeah, exactly. SpaceX.
Yep.
Yes, please.
So with mention of this exploration for playing land and stuff, I was just sort of wondering how that would work nowadays, because if some company goes out, they find a big mine or something, how do they make sure that they can actually mine all the stuff from there and someone might just follow right behind them and steal all the resources or something?
For that, we have United Nations Office of Outer Space Affairs. They are making the rules, and the rules are still, and it's very difficult to make. Anyone knows better than me.
They have some rules. They're insufficient rules.
But if they're enforced, it'll be to the same extent that international law is enforced, which is only if you sign up to it, which a lot of countries aren't.
Yeah.
You've got no preparation agreements.
It's a very lucrative area for lawyers.
So would it be really, really profitable to not be thinking about space mining, but space theft? You wait for another country to invest in the ability to mine something, but then come up just after they're taking their load back down to Earth and redirect it. It'd be much cheaper.
You can't do.
Or maybe we can learn from the past.
You can't do that according to UN law, though. So if you're going to be doing anything on,
Well, every technological advancement has its disadvantages also, and we have to be careful about disadvantages. Yes.
Your participation in this conference, if that's the right word, what was the greatest benefit to yourself and to the group in the experience?
Benefit from the was that I got an audience for my paper, for my research work. That is one for my career, and other thing is that interacting with the field, experts on the field, that gives you enthusiasm to do something more. What I would say that what I would have thinking before IAC to where I can reach, and now my expectation on myself has been extended. So I want to do some more now. So that I would say that is the impact.
How would you spread the benefits of all this space technology to developing countries?
To developing countries, how? Very easy answer is social media. But no, there are in developing countries there are people who are active on spreading the awareness on space, and even IAF has a Space Generation Advisory Council, the youth wing of space industry. They are also active on that matter. So it's a slow process, but the awareness is increasing.
It'd be nice to work out how we can do it in Australia. Spread some benefits of the space industry. Anyone, another question?
In regards to space mining, is the goal of it to produce an economy in space where you're using the materials in space, or to bring them back to Earth? Like, what is the ultimate goal, or the initial goal rather?
Easier way is to use the whatever produced in space, use those in space. Bringing them back is much more difficult.
Yeah, we've had a girl over in the School of Mining Engineering who's done a study on an iron ore asteroid. It's basically like solid stainless steel. And it was quite an easy asteroid to get to, so it was a good example. And return on investment using the resources on Earth, 85 years. Return on investment using it in space is 5 years. So no one's going to invest in the Earth version. The space version is feasible. there's lots of unknown risks and stuff, there are lots of assumptions, but that's a fairly indicative.
But first we have to know how to use those materials in space.
That's it. That's what I was saying earlier. There's a chicken and egg thing, right? We need to find and get the market going in space. And supply, or the other way around. And that is the biggest problem that will be discussed at the Off Earth Mining Forum in Sydney in November 2015. For those of you that are interested, which I'm the chair.
What's the registration fee?
For students, not much. I will stay a student for that period of time.
How much?
No, we're running it in parallel with the future mining conference. So there's miners there and there's space people there in the same place at the same time. The mining conference, quite expensive. The forum, moderately expensive but cheap.
So space people are allowed near miners. They don't need like working with children check grades.
Well, the problem we had with the last forum was we didn't get enough miners. We didn't get any of the mining companies to come, but we did get individuals who were interested in the mining companies. So this time we're forcing the mining companies to be in the same place and we'll see what we can do.
Yes.
What are some of the newest technologies in space? Like some examples.
Newest technology in
Space. Just use in space or something in that field.
You want to know whether it's applied in art or in space? I mean, there are a lot of things, and it's hard. Pointing out is very difficult.
What school are you from?
Mechatronics or mechanical.
Mechanical examples.
Mechanical examples. One example is there, which is not currently not using in space, but it is used in USA. School bus chassis. The structure of school bus chassis actually were developed by NASA, and which is more impact resistant than the previous one. So,
can you explain what school bus chassis?
I am not from mechanical background.
Chassis.
Chassis.
What
The structure.
The structure.
There are quite a few new propulsion systems that might be of interest to you guys. They're going to launch a solar sail next week or something for the first time.
What about on-orbit assembly?
On-orbit assembly is a good example of this. There was a guy here called Gordon Ressler. He worked with us for a year. He's now at DARPA. So he's working on that. So if anyone has an interest in on-orbit assembly, I'll put you in charge with the main guy. So what they're doing is, sending up bits of satellites and putting them together in space. And on-orbit servicing as well as an on-orbit. So going around like a petrol tanker, filling up the satellites so they can orbit. No more questions? All right, thanks everybody.